Hello, everyone, and welcome to this webinar. My name is Lodovico Giaretta, and today I will talk to you a little bit about data marketplaces, what they are, what are the current challenges, and what are potential future directions for their development. Now, to understand data marketplaces, we first need to understand the data economy. And so you might have heard before this thing that data is the new oil. And now, how much this analogy is actually correct and realistic, well, you will find different opinions on the matter. But what everyone agrees on is that nowadays, data-driven companies are some of the most successful in the world, even more than energy providers that are traditionally quite big. And this is because more and more aspects of our world now rely on data-driven services to work. And here you might be thinking about digital services. You might be thinking about the experiences that you have online and how those are driven by data. But actually, even experiences and activities in the physical world are nowadays often data-driven. Think, for example, about logistics and transportation. These are fields where data-driven modeling and forecasting have become key to success of the operations. And one problem in this area is that all these data-driven services, to be so good and successful, they often require large amounts of high-quality, very granular data. And not only that, but they often require high-quality granular data from multiple domains. So they require the combination of data from multiple different sources, from multiple different domains, in order to extract the insights necessary for the service. And of course, getting all this high-quality data is actually quite hard, and this is the challenge. So let's keep with our metaphor of data as the new oil, and let's look a little bit at what is a typical workflow to get and exploit data. So first of all, we need to find data, find good, useful sources of data. Once we found them, we then need to extract the data. And traditionally, we tend to think of extracting the data as taking it out of the source device, so collecting it instead in a central location. But that is not strictly necessary. So the key thing is that the data must be made accessible. It must be made available for downstream tasks. And so, of course, collecting the data is one way to make it accessible, but it's also possible to keep the data on the source devices and just prepare it in such a way that it will be accessible and available on demand for the task that you will need to run on it. And now, once you have data that is accessible and available to be used, then what you need to do is that you need to refine the data. And this typically means that the data needs to be cleaned, it needs to be pre-processed, and as I mentioned, it often needs to be combined with data from other domains, and all of this in order to make higher quality data, so data that is capable of providing better, more accurate or deeper insights. But in addition to this, once you have your high quality data, you might also want to run some data analytics or some machine learning on it to be able to actually extract these insights that are now contained in your data. So to be able to extract actionable information from your data. And once you've done all of this, your end goal is then to monetize your data or to monetize the insights that you get from the data. And you can do this in different ways. You can do this by building internal services, so services that are used within your business in order to optimize it. So, for example, you could use data-driven services for forecasting, and so for logistics or for cost saving, cost optimization, delivery optimization, basically optimizing the cost and time it takes to deliver your products. Or another way is that you could build services that are instead customer-facing, external services. So services that you can sell to your customers and therefore get one additional source of income, one additional revenue stream for your organization. Or you might be in a situation where you are not in the condition to use the data directly for building any useful service. You haven't found any actual way to exploit this particular data that you have, or there is just no way that you can use it directly. In that case, what you might want to do is you might want to sell your data or sell your insights, because chances are there are other companies out there, maybe even in different domains, who are interested in this kind of data, who are interested in the data you can offer, because they could then integrate it in their systems to improve their processes or to improve their services. So by selling the data to these companies, you can then generate value for yourself by enabling them to produce value for themselves. And so this is where data marketplaces come into the picture. Data marketplaces are just services that allow different companies or different organizations to buy and sell data. And here, let's again oversimplify things and discuss what is a typical workflow. So first of all, we have sellers who have data they want to sell. They will upload this data to a marketplace. They will then add the metadata describing what kind of data is this, what kind of information is contained in it, how was it collected and when. And in addition to metadata, they also typically set what kind of pricing model they have. So is this a one-time purchase to download the data? Is this some kind of subscription system where you can subscribe and pay monthly to get updates to the data constantly? So this kind of information from the seller side. Buyers, on the other hand, they have a need for data, and therefore they go and search in the marketplace, search for useful data using the metadata available as a guide. And once they find useful data, the buyers can then pay the agreed price, enter in the established contract, and then they can get access and maybe download the data. And so let's look at what are the main characteristics of data marketplaces as of today. Well, first of all, they are almost exclusively B2B, business to business. So both the buyers and the sellers are companies or organizations. And also, the environment here is highly fragmented. So there are a lot of marketplaces out there, and they all differ from each other. Some are very small, some instead are quite big. Some work with any kind of data, others instead they have a selling point, the fact that they specialize in data for particular domains and they offer custom tailored services for those domains. These marketplaces also often have quite different payment structures of how buyers and sellers interact from a payment perspective, and also different business models for how the marketplaces themselves make a profit. And crucially, they also provide very different fields and structures and formats for providing metadata and for searching the marketplace for data. So they provide quite different user experiences for buyers and sellers. So now that we've seen the status quo, let's now move to look at what are some of the open challenges that we can see in the current state. And let's also look at some potential directions, potential solutions to overcome these challenges. And the first challenge is that of data discoverability. And here, as I mentioned, the key point is that we have many small marketplaces available. And a seller might ask, where should I put my data? In what marketplace should I put my data to maximize its monetization? And how can I describe and tag my data? What metadata can I use to ensure the maximum spreading of my data to the maximum number of buyers who might be interested? And on the other hand, a buyer might ask, well, where should I look for useful data? What keywords should I use in my search? And how do I make sure that the data that I'm seeing in the marketplaces will actually be useful for me, that it will actually contain what I need? And the key problems here are the fragmentation of the industry. So the fact that there are so many marketplaces, but also the lack of standardization. The fact that every marketplace has a slightly different structure, different user experience, different metadata. And so each marketplace acts a little bit like a closed silo with its own tiny environment that is completely isolated from the rest of the data economy. So what could we do here to solve this problem? Well, what we argue is that the different marketplaces and the different stakeholders in the data economy should team up and form a consortium or a federation of marketplaces. And this consortium could then work, for example, to standardize what are the metadata formats and what kind of information and user experiences there are. And also provide a standardized open access to the metadata, machine-readable open access to the metadata. And these would then enable third-party services to be built on top of this open metadata from the entire consortium. And these third-party services could provide additional value for buyers and sellers to interact with the marketplaces. And this could include, for example, holistic search engines who can crawl the open metadata across the consortium and therefore provide a unified search experience for the buyers. In a sense, these would make data marketplaces behave similarly to the web right now, where, if we think about it, there are a lot of different websites with many, many different web pages, and yet all of these can be crawled by third-party services, by companies who specialize in constructing search engines, and so provide a unified search where you can find any publicly accessible web page from one location. And in the same way, data could become searchable like web pages if there was open and standardized access to the metadata. Now, the second challenge is that of data privacy. And the key problem here is that when buyers buy data, what they are effectively getting is the chance to download a copy of the data from the marketplace. But the problem with the data is that it's an intangible good that can be easily shared with anyone. And there is no simple way to check who the data is being shared with once it has been downloaded. And also, once it's been downloaded, data can be used for virtually any purpose, and there is no practical way to limit the way the data can be used. So all of this means that the seller must then trust the buyer, trust that the buyer will not share the data with others unless authorized, and will only use the data for usages that have been authorized by the seller. And this need for trust becomes even more problematic once personal data comes into the mix. So how can we sell personal data in a way that is legal and ethical, considering all the implication and all the risk of data leakage, and also all the regulations such as GDPR? And here, one potential solution is the area of blind computing techniques. So these are a wide family of techniques that allow running computations on data without actually being able to see the data directly, without being able to use the data for anything other than running these computations. And here, there are multiple approaches that have been developed. And each approach has different pros and cons. The most famous are secure multi-party computation, homomorphic encryption, and trusted execution environments. Now, we will not go into the details of all these approaches, but let me give you a quick example of how trusted execution environments work from a very high level perspective. So let's here look at our setup. We have a producer with some data, and we have a consumer who has a task that they want to run on the data. For example, they might want to train a machine learning model on the data of the provider. Let's now introduce a mediator. So a third party that has some computational resources and maybe some storage and memory resources. Now the mediator can create a trusted execution environment that encapsulates part of the computing resources available and also provides an encryption key, cryptographic keys that can be used only within the trusted execution environment. And now what happens is that the producer can then safely send its data to the trusted execution environment, or TEE for short. So can send the data to the TEE in a safe, encrypted way. And similarly, the consumer can send the code that needs to be run to the TEE, again, in a secure way. The TEE will decrypt code and data, run the computation, and then encrypt the result and send it back to the consumer. And while all of this is happening, no one can have access to the internals of the TEE. No one can actually look at the code, all the data when it is decrypted. Not even the mediator who owns the hardware is able to actually look what's going on inside. And if the TEE needs to access some external resources, for example, the storage in the mediator node, it will also do that using cryptographic keys so that it is also safe and unreadable to other parties. At the end, the TEE can also provide certificates to both the consumer and producers that certify that the computation has been performed correctly without any leakage and without any tampering with the information. So now that we've seen a simple setup for data privacy, let us now move to the third challenge, which is that of data valuation. And here the problem is, from a seller perspective, how can we tell how much our data is worth? How can we find out how much we should charge for our data? And from the buyer side, how much should the buyer pay for some data? How much value can they get from it? How can they know that? How can they deduct that? And the key problem here is that the value of the data is not fixed. Rather, it is usage dependent. The same data might be extremely valuable for someone, but not that valuable for someone else, depending on what domain they are working on what kind of task they're trying to solve, what kind of problem they're trying to solve. Not only that, but to make matters even more complicated, the value of data also depends on what other data it is combined with. So a data set, for a specific usage, a data set could be completely useless unless it is combined with another data set. And at that point, it becomes very valuable. Or, on the opposite side, you could have two data sets that might seem quite different from each other, but actually provide the same insights, provide the same information for a given usage. And therefore, if you already have one of them, the other one becomes worthless to you because it cannot provide any additional value to what you already have. Therefore, what we're learning here is that the price of the data must depend on its utility for a specific buyer, for a specific use case. And not only that, but the price of the data must be set by considering the context in which the purchase is made, by considering what other data is available. And so here, in the context of data valuation, there is no simple, straightforward solution that can be applied to answer these questions. However, there are at least two strategies that can be employed to help find the reasonable answers to these questions. So the first strategy is what we can call an a priori strategy. And here, from the buyer's perspective, we want to pay the expected additional value that we can extract from a data set. And this means that we start by considering what other data sets we already have, or we already purchased, or we already decided to purchase. And considering this, we now need to decide how much additional value the next data set will provide, to decide how much to pay for it. But to decide this, we need to use some kind of application-specific proxy metric. So a proxy metric that we can apply that can allow us to basically deduct how much information, how much value this dataset will provide us once we buy it. And so this is the first strategy. The second strategy is what we could consider an a posteriori strategy. And here, the idea is that finding this application-specific proxy metrics and estimating the additional value of the data is quite hard. So let's instead not do that, and let's instead pay after we use the data. Because after the data has been used, after the task has been performed, the buyer knows how much value has been extracted. They know, for example, how accurate the machine learning model is, or how good their model is in production. So now they know, the buyer knows what is the overall value they got. However, what the buyer does not know in the a posteriori case is if multiple datasets were bought, how much of that value came from each dataset, how much each dataset contributed to the overall success of the task. And so there is here a need to split this combined value and to estimate the contribution of each dataset to the overall value. And so neither of these approaches is really straightforward. They both have a challenging part. Either there is the challenge of having some kind of proxy metric in advance, or the challenge of splitting the value afterwards. And also in both cases, there is a trust issue. In the a posteriori case, because the buyer is the only one who is capable of splitting the value, then the seller must trust that the buyer correctly measured and split the value and paid the fair amount to every seller. But in the a priori case, because the buyer does not have access to the data yet, then the buyer must request that the seller provides this application-specific proxy metric. And so the buyer must trust that the seller is not cheating and providing a higher metric than it is in reality. And so in both cases, of course, we can use TEEs or trusted mediators to fix this, but it's one more complication in this data valuation context. So the final challenge that we have is that of integrating private individuals in the data economy. So here, as I mentioned, the problem is that data marketplaces are almost exclusively B2B, business to business. So no private individuals, no individual persons are involved in the marketplaces typically. And therefore the question arises, should private individuals actually be part of the data economy, be part of this buying and selling data? And here, the key point is that the data economy will increase the movement of data and will increase the usage and will increase the exploitation of data, increase the value that society extracts from the data. But if we drill down, this data, or at least most of this data, ultimately comes from private individuals, ultimately comes, yes, from companies, but from user data collection activities that these companies perform. Companies obtain data mostly by collecting information about their users and about their behaviors and about how the customers interact with the company. And so what happens here is that most data is ultimately produced by private individuals, But private individuals do not have any control over it because the data is being sold and used by businesses. And the private individuals also do not directly benefit from this additional monetary value that the data sellers are getting. On the other hand, though, there are also points against this, at least for the moment. So, for example, one could say that it is true that private individuals do not directly gain a monetary benefit, but they indirectly benefit from the additional better services that are provided to them. And also, one might argue that it might not really be so easy from a technical perspective to integrate billions of individuals into this data marketplaces landscape. And also, it is not totally clear how the economics would work, whether the economics would make sense of having individuals directly selling their data to third parties. And so this is very much an open question, open for debate, and open also for interdisciplinary considerations between not only computer science, but also economy. So with this, we reach the end of this discussion. I hope you found this discussion of data marketplaces and future directions to be interesting. And here I will leave you with a few sources where you can read a little bit more on the topic of these slides. So thank you very much for listening, and see you at next webinar. Bye-bye.